Have you ever looked up at the night sky and wondered if we're truly alone, or if there are places out there so strange, so utterly beyond our imagination, that they defy everything we think we know? Deep space is filled with mysteries, unexplained phenomena, cosmic puzzles that have baffled scientists and dreamers alike for generations. But among all these enigmas, there is one region that stands out, a place so shrouded in secrecy and speculation that it has earned a legendary, almost mythical status among astronomers: the forbidden sector between Alpha and Beta Centauri. Picture this: two of the brightest stars in our sky, Alpha and Beta Centauri, glowing with an almost hypnotic intensity. They're among our closest stellar neighbors, yet nestled between them lies a zone that has provoked more questions than answers. It's a place where conventional laws of physics seem to fray at the edges, where strange energy readings flicker in and out of existence, and where some of the most advanced telescopes humanity has ever built have returned images that simply don't make sense. This is not science fiction. This is one of astronomy's greatest unsolved puzzles, a real-life cosmic riddle waiting to be unraveled. What could be hiding in that silent, dark expanse? Is it a natural phenomenon unlike anything we've encountered? Or could it be something else entirely, something that challenges our very understanding of reality? In this video, we're going to journey together into the heart of the forbidden sector, exploring the theories, the mysteries, and the breathtaking possibilities that lie within. You're about to embark on an adventure that spans the reaches of human curiosity and courage, one that asks not just what's out there, but what it means for all of us here on Earth. So settle in, open your mind, and get ready to explore one of the universe's most compelling secrets. To truly grasp the mystery of this place, we first need to understand exactly where it is. Nestled within the sprawling, ancient constellation of Centaurus, the forbidden sector occupies a relatively small but profoundly significant patch of space. Its boundaries are defined by its two brilliant sentinels, Alpha Centauri, the closest star system to our own Sun, and Beta Centauri, a distant but incredibly luminous giant. If you were to draw an imaginary line between these two celestial beacons, the forbidden sector would lie just off-center, a region of profound darkness that seems to swallow light itself. Its astronomical coordinates place it in a zone that should, by all accounts, be buzzing with the background hum of the universe, the gentle whisper of cosmic radiation, and the faint glow of distant stars. Yet it is conspicuously, unnervingly quiet. So, why has this specific area earned such a dramatic and foreboding title? The term forbidden wasn't born from superstition, but from cold, hard data and a series of frustrating, even frightening technological failures. Early radio telescopes pointed in its direction reported not the expected static of deep space, but an unusual null signal, a profound silence that was paradoxically louder than any noise. It was as if something was actively absorbing all electromagnetic emissions, creating a void in the spectrum. Later, when more advanced probes and space-based observatories were trained on the sector, their readings became erratic. Sensors would malfunction, instruments would report impossible data like negative energy densities or temperatures approaching absolute zero in localized patches, and guidance systems would inexplicably drift off target. It became clear that sending a manned mission through this region would be akin to navigating a ship through a minefield blindfolded. The risk of catastrophic systems failure was and remains unacceptably high. This combination of inexplicable phenomena and tangible danger led the global astronomical community to unofficially label it as forbidden. It's a zone that is effectively quarantined by its own bizarre properties, a place that defies observation and resists exploration. It's not that we aren't curious, it's that every tool we've used to look at it either breaks down or feeds us information that contradicts fundamental physics. This designation is less about a rule and more about a stark acknowledgement of our own limitations. we are faced with a cosmic puzzle that we simply do not yet have the pieces to solve, a literal blind spot in our map of the universe that challenges our very understanding of reality. Long before modern telescopes ever detected its strange silence, this patch of sky held a powerful and often unsettling fascination for those who studied the stars. Ancient cultures, whose knowledge of the heavens was woven into their mythologies and survival, noticed there was something different about this particular part of the constellation Centaurus. The Greek astronomers, for whom Centaurus represented a mythical half-man, half-horse creature, documented this region as a place of astronomia affanes, a term meaning unseen astronomy or starless knowledge. In their meticulous star charts, this area was often deliberately left blank, not as an oversight but as a recognized void. They understood the patterns of the cosmos with incredible precision, which makes their conscious omission of this sector all the more telling. It was as if they were acknowledging a fundamental gap in the celestial tapestry. Halfway across the world, indigenous Australian astronomers, whose oral traditions contain some of the oldest recorded star knowledge on Earth, told stories warning of a dark emu in that part of the sky. In their cosmology, the emu is a powerful creator spirit, but this particular dark shape was not a source of life. It was described as a hungry mouth that consumed the light of the surrounding stars. These weren't just fanciful tales, they were sophisticated ways of encoding observable celestial behavior. Their descriptions of a light-swallowing presence align eerily well with the anomalous null signals our radio telescopes would detect millennia later. The mystery only deepened with the advent of the telescope. In the 18th century, pioneering astronomers like Nicolas Louis de Lacaille catalogued the southern skies with revolutionary new instruments. Yet, when his logs reached this specific region, his notes became fraught with confusion. He reported a most peculiar blackness that his lenses could not penetrate, noting that stars directly adjacent to this darkness appeared dimmed and quenched, as if viewed through a faint, invisible veil. He initially assumed a defect in his equipment or a localized cloud of cosmic dust, but further observation ruled out both explanations. This was one of the first recorded instances of a trained scientist documenting the sector's anomalous nature, dubbing it a void of perplexing quality. The true turning point arrived in the early 20th century with the dawn of radio astronomy. When scientists first began listening to the cosmos, they expected the constant hiss of cosmic microwave background radiation, the leftover static from the Big Bang. Every direction in the sky confirmed this except for one, pointing their massive dishes toward the space between Alpha and Beta Centauri. Researchers were met with a profound and utter silence. It wasn't merely an absence of signal, it was an active cancellation, a void so complete it seemed to defy the laws of physics itself. This was the moment the region shifted from being a curious anomaly to a full-blown scientific enigma. The term forbidden sector began to circulate in academic papers, not as an official designation, but as a grimly humorous acknowledgement that every time we tried to look there, our technology either failed or fed us nonsense. This historical thread, from ancient mythologists to modern radio dishes, paints a compelling picture. It suggests that the strangeness of this sector is not a new phenomenon. It has been a constant, unchanging feature of our universe, silently resisting observation across centuries and across entirely different methods of inquiry. This consistency tells us one thing for certain: whatever we are dealing with is not a temporary glitch or a passing cosmic weather pattern. It is a permanent and profound feature of our reality, one that has been waiting for us to develop the tools and the courage to finally understand it. This profound and unsettling quiet stands in stark contrast to the vibrant cosmic chorus we detect from virtually every other direction. For decades, projects like SETI, the search for extraterrestrial intelligence, have scanned the heavens, their massive radio telescope arrays sifting through the constant hiss and crackle of the universe, listening for a pattern, a signal, anything that might indicate we are not alone. These searches have yielded fascinating anomalies and tantalizing possibilities, but the one place they have consistently found absolutely nothing is the forbidden sector. It's not just silent, it is the definition of radio silence, a perfect void in the electromagnetic spectrum. While other regions of space whisper with the background radiation of the Big Bang, hum with the radio waves of distant pulsars, or occasionally offer a curious blip that sends scientists scrambling, this sector offers only a perfect, unbroken null reading. It's as if a giant, invisible curtain has been drawn across that part of the cosmos, muting it completely. This great silence is so extreme that it defies simple explanation. A common thought might be that it's just an empty region of space, a vast cosmic desert without any stars or planets to generate a signal, but that's simply not the case. Our optical telescopes confirm that this sector is far from empty. It contains countless stars, nebulae, and at least 2 known exoplanets orbiting within the habitable zones of their suns' worlds that, by all our current understanding, could potentially support life. The silence isn't due to a lack of sources. It appears to be caused by something actively suppressing or absorbing all transmissions. Imagine standing in a crowded, noisy stadium where everyone is shouting, yet one specific seat is shrouded in absolute perfect quiet, as if the sound itself is being sucked into a void. That is the enigma we face. Scientists have proposed several theories to account for this phenomenon, each more mind-bending than the last. One possibility is the existence of an immense yet undetectable interstellar medium within the sector, a cloud of exotic particles or a form of dark matter so dense that it acts as a perfect electromagnetic sponge, soaking up every wavelength of energy that passes through it. Another, more speculative idea involves a natural gravitational lensing effect of unimaginable scale, where the fabric of space-time is warped in such a precise way that it bends all signals away from our detectors, effectively hiding the sector behind a relativistic cloak. Then there are the theories that venture into the realm of the extraordinary. Could this silence be artificial? Is it the hallmark of a Kardashev Type 2 or 3 civilization, one that has mastered energy on a galactic scale and has chosen, for reasons beyond our comprehension, to shroud its presence entirely? A civilization that doesn't broadcast its existence but instead engineers its environment to be perfectly quiet, a cosmic stealth technology of epic proportions. This last possibility is what makes the great silence so deeply provocative and, for some, deeply unsettling. The famous Fermi paradox asks, if the universe is so vast and ancient, where is everybody? The forbidden sector might just contain a potential answer. What if they are there, but they are deliberately silent? What if they have chosen to quarantine themselves, or perhaps to quarantine us from them? The complete absence of a signal in this context could be the most powerful signal of all. It forces us to confront the unnerving idea that the ultimate sign of a vastly advanced intelligence might not be a welcome message beamed across the stars, but a profound, intentional, and impenetrable silence. It suggests a universe where the most powerful players are not those who shout the loudest, but those who have mastered the art of staying completely hidden. Yet the gravitational anomalies extend far beyond mere lensing effects, hinting at something even more perplexing hidden within the void. Space telescopes equipped with incredibly precise instruments have mapped the sector's gravitational field, and the data reveals mass concentrations that simply should not exist. These aren't just large planets or failed stars. These are gravitational signatures of immense objects that emit no light, generate no heat, and remain completely invisible to every other type of observation. They are, for all intents and purposes, ghosts, colossal masses with no physical form we can detect. According to our current understanding of physics, an object with that much mass must be visible. It should radiate energy, distort space around it in predictable ways, or at the very least, reveal itself through its influence on nearby stars. But in the forbidden sector, these rules appear to be broken. The masses are there, their gravitational pull is undeniable, but they are otherwise absent, acting like cosmic anchors made of nothing at all. One of the most startling observations involves the behavior of light from galaxies that lie directly behind the sector from our perspective. Instead of being lensed into the characteristic Einstein rings or arcs we see elsewhere in the universe, the light from these distant objects is often fractured. It appears to split into multiple, faint and shimmering copies that shift and change in ways that make no logical sense. At times, the light from a single galaxy will appear in several places at once, flickering like a mirage before one of the images winks out entirely. This isn't the clean, predictable bending predicted by Einstein's theory of general relativity. It's chaotic, almost as if the fabric of spacetime itself is unstable within the sector, rippling with distortions we cannot explain. It suggests the presence of gravitational forces that are not only immense but also fluctuating, as if these invisible masses are moving or changing in ways that defy our concepts of solid matter. Theoretical physicists have been left scrambling for answers, proposing models that sound like they belong in a fantasy novel. Some suggest these could be primordial black holes from the very dawn of the universe, clustered together in a way we've never observed, creating a tangled knot of gravity wells. Others speculate about the existence of stable wormholes, not just theoretical constructs, but actual functional tunnels in spacetime whose immense gravitational mouths could account for the bizarre lensing and the apparent lack of any visible source. Perhaps the most radical theory involves a form of matter that interacts only through gravity, a shadow substance that does not respond to the electromagnetic force at all, making it completely dark and undetectable except for its irresistible pull on the fabric of the cosmos. What makes these gravitational mysteries so deeply significant is that gravity is the universe's great architect. It governs the motion of planets, the formation of galaxies, and the very expansion of the cosmos itself. To find a region where gravity behaves in a way that is fundamentally alien to our models is to find a crack in our understanding of reality's foundation. It implies that there are forces at work or states of matter and energy that we have not yet dreamed of. These aren't just unknown objects, they are unknowns that challenge the very equations we use to define the known universe. If our tools of discovery are telling us that our foundational physics is incomplete, then the forbidden sector is not merely a puzzle to be solved, it is a teacher waiting to show us an entirely new chapter in the book of cosmic law. When the most familiar forces in the universe fail to provide an answer, science must turn to the most mysterious. This has led a growing number of cosmologists to propose a radical idea, that the heart of the forbidden sector may not be dominated by strange matter, but by the very force that is causing the entire cosmos to expand at an accelerating rate. We are talking, of course, about dark energy. This enigmatic pressure, which makes up about 68% of the universe, is the dominant component of reality, yet we know almost nothing about it. We cannot see it, touch it, or measure it directly. We only observe its effects on the largest scales as it pushes galaxies apart from one another. The prevailing theory is that dark energy is a property of space itself, a constant, uniform background energy that is identical everywhere. But what if that's not entirely true? What if dark energy can pool and collect like water in a cosmic basin? The bizarre properties of the forbidden sector could be the first evidence that it does. Imagine a region of space where the dark energy isn't a faint, uniform whisper, but a roaring, concentrated vortex. In such a place, the very fabric of spacetime would behave in ways that appear to break our physical models. The profound radio silence could be explained by this dense, exotic energy actively repelling the quantum fluctuations that normally give rise to particles and waves, creating a true void. The strange gravitational lensing and phantom masses could be the result of this energy warping spacetime not with gravity, but with a powerful, repulsive anti-gravity effect. A sufficiently dense knot of dark energy wouldn't pull on light like a black hole. It would push and distort it in chaotic, unpredictable ways, creating the fractured, shimmering mirages our telescopes have observed. It would be a gravitational repulsor, not an attractor, explaining how we can detect immense mass without finding any visible object to account for it. This hypothesis also offers a terrifyingly elegant explanation for the sector's historical reputation as a place of danger and technological failure. The Pioneer and Voyager probes, which traveled through the outer solar system, experienced a tiny, unexplained acceleration that has never been fully accounted for, a phenomenon known as the Pioneer anomaly. Now picture that effect multiplied a billionfold. A spacecraft venturing into a concentrated field of repulsive dark energy wouldn't just have navigation problems. It could be violently pushed apart or have its atomic bonds strained to the breaking point as the space within the ship itself began to expand at a different rate than the space outside. This isn't just a communications blackout, it's a physics blackout. The sector is forbidden not by decree, but by the fundamental laws of nature operating there in a way that is utterly hostile to the structured matter from which we and our technology are built. Yet, the dark energy hypothesis, while compelling, is not the only exotic matter theory on the table. Another fascinating possibility involves quantum anomalies, specifically the concept of vacuum decay. The quantum vacuum that makes up empty space is not truly empty. It's a seething, bubbling foam of virtual particles popping in and out of existence, held in a state known as a false vacuum. This is our universe's stable, albeit tenuous, ground state. Theoretical physicists have long speculated that a more stable, true vacuum state could exist. If a bubble of this true vacuum were to spontaneously form somewhere in the universe, perhaps due to a high-energy event, it would expand at the speed of light, rewriting the fundamental constants of physics within its reach. The laws of nature inside that bubble, the strength of gravity, the mass of an electron, could be completely different from our own. The forbidden sector could be the site of such a bubble. Its silence and bizarre properties wouldn't be caused by something there, but by the absence of the quantum noise that defines the rest of our reality. We wouldn't be looking at a strange object in our universe, but a tiny, growing piece of an entirely different universe with entirely different rules, a cosmic cancer that has replaced our physics with its own. Whether it's a pool of raging dark energy or a bubble of alien physics, the implication is the same. The forbidden sector might be a place where the universe is fundamentally broken. It is a wound in the fabric of reality, a zone where the rules as we know them do not apply. This transforms it from a mere astronomical curiosity into a site of profound philosophical and scientific importance. By studying it, we are not just looking for answers about one strange patch of sky. We are peering into the underlying mechanics of existence itself, testing the limits of our models against a reality that is far stranger and more malleable than we ever dared to believe. The logical next step, of course, was to go and see for ourselves. If our telescopes and listening posts were failing, then we would send our robotic ambassadors directly into the darkness. The result was a string of some of the most expensive and perplexing failures in the history of space exploration. These weren't simple malfunctions, they were cascading, inexplicable system collapses that read like a catalogue of technological nightmares. The first dedicated probe, named Pathfinder 1, was launched in 2038. It was a robust, heavily shielded vessel designed to withstand intense radiation and micrometeoroid impacts. Its mission was a simple flyby to capture the first close-range visual data of the sector. For the first 90% of its journey, everything was nominal. Then, as it crossed the theoretical threshold into the sector, its transmissions began to degrade, not with static but with a bizarre digital decay. The images it sent back became glitched and fractured, as if the probe's cameras were looking at a reality that was itself pixelated and unstable. Its final transmission wasn't a cry for help or an explosion. It was a single, looping data packet containing a temperature reading of absolute zero, which is a physical impossibility in the vacuum of space, followed by utter silence. This pattern repeated itself with maddening consistency. Probe after probe, each more advanced than the last, was sent to investigate. Some, like the Kepler observer, simply vanished the moment they entered the sector's influence, their transponders blinking out of existence as if they had never existed at all. Others suffered what engineers termed catastrophic physics failures. The Daedalus Array, a probe equipped with sensitive gravitational wave detectors, reported a sudden and massive spike in localized gravity a millisecond before its structure was compressed into an unrecognizable cube of molten metal and circuitry. It was as if the probe had been instantly crumpled by an invisible fist. The most chilling failures were those involving time. The Chronos probe, designed to measure time dilation effects, began transmitting its data. But the timestamps on the information were from 48 hours in its own future. For 3 minutes, Mission Control received a peaceful, detailed account of its own successful mission from a probe that, in their present timeline, was currently screaming emergency alerts as its systems failed in real time. Then the signal ceased and the probe was gone. All of these mysterious events culminated in the most famous and devastating loss, the Centauri 7 mission in 2042. This was not a simple probe. It was a flagship-class autonomous explorer, the size of a small bus and equipped with the most resilient and redundant systems ever conceived. Its mission was not a flyby, but to enter a stable orbit within the heart of the sector for a full year of intensive study. The world watched its launch with bated breath, hoping this technological titan would finally crack the mystery. For weeks, its journey was flawless. Then, on the day it was scheduled to initiate its braking maneuver and enter orbit, Mission Control received a final, broken transmission. The video feed showed the interior of the probe for a few seconds, completely normal, with the gentle hum of machinery. Then, the image flickered. For a single frame, the camera's view was replaced with what appeared to be a view of infinite, impossibly black stars against a stark white background, a perfect negative of the cosmos. In that same instant, the audio channel captured a sound that defies description. Not a bang or a screech, but a low, resonant tone that seemed to cancel out all other noise. And then nothing. Centauri 7 vanished without a single piece of debris, without a final explosion, without any further data. It was just gone, leaving behind only that haunting final frame and a silence that has echoed through the scientific community ever since. The official report listed the cause as an encounter with an unknown and unsurvivable anomalous phenomenon, a phrase that perfectly captures our utter lack of understanding. These vanished probes serve as the most direct and terrifying evidence we have. They tell us that the forbidden sector is not just a place of strange readings, it is actively, and perhaps intelligently, hostile to our attempts to observe it. These inexplicable technological failures are matched only by the equally puzzling and deeply personal accounts from the handful of astronauts who have journeyed near the sector's periphery. Their testimonies offer a human perspective on the anomaly, one that moves beyond cold data and into the realm of raw sensory experience. While no crewed mission has ever been authorized to enter the forbidden sector directly, several have traveled along its fringes during broader exploratory missions, and their reports are strikingly consistent. Commander Eva Rostova, a veteran of the International Orbital Outpost, described a routine supply run that brought her vessel within a few astronomical units of the sector's accepted boundary. She recounts that during a period of scheduled rest, she was drawn to the observation cupola by an unusual, rhythmic flickering from the direction of Centaurus. What she saw was not a star nor a nebula, but a faint, pulsing light that seemed to beat like a heart in the void. It would glow a soft, impossible magenta, then vanish completely, only to reappear seconds later in a slightly different location, all without any discernible pattern. Her initial thought was an instrument panel reflection, but blocking the interior lights of the station did nothing. The phenomenon persisted for nearly an hour, a silent, arrhythmic beacon in the darkness that seemed to defy both explanation and the very laws of motion. Perhaps even more compelling are the reports of instrument malfunctions that accompany these visual events, glitches that seem to target the very systems designed to keep astronauts safe. Major Kenji Tanaka, piloting a long-range survey craft, experienced a complete momentary failure of his navigational gyroscopes as his ship's trajectory brought it into indirect alignment with the sector. For approximately 30 seconds, his craft's internal guidance system insisted it was spinning wildly, yet his external star trackers and his own visual confirmation showed he was in perfect stable orbit. It was a sensory disconnect of the most terrifying kind, a direct conflict between what his instruments screamed was true and what his own eyes and inner ear confirmed was reality. He described it as a profound vertigo, not of the body but of the mind, as if reality itself had developed a stutter. The systems reset themselves just as suddenly as they failed, leaving no error logs or diagnostic clues behind. Ground control later confirmed they observed a bizarre data spike from the craft's orientation systems at that exact moment, but could find no cause. This suggests these events are not hallucinations, but measurable, physical interactions that directly affect complex electronics in ways that leave no permanent trace. What makes these astronaut accounts so critical to the mystery is their shared, visceral nature. These are not remote observations made from the safety of a laboratory on Earth. They are direct, first-hand experiences from highly trained observers operating at the peak of human performance. These individuals are experts in distinguishing between celestial phenomena and potential spacecraft issues. Their unanimous description of a profound wrongness, a feeling of disorientation, of being watched, or of reality itself being subtly but undeniably off carries a weight that raw data alone cannot. It points to an effect that is not just electromagnetic or gravitational, but one that may interact with human consciousness itself. The sector doesn't just break our machines, it seems to challenge our perception, suggesting that whatever lies at its heart may be so fundamentally alien that it warps not only space and time, but the very act of observation. These brave men and women became unwilling participants in an experiment they never signed up for, and their stories provide the most haunting evidence yet that the forbidden sector is not a passive mystery, but an active and perhaps even aware phenomenon. If the bizarre gravitational effects and technological failures weren't enough of a deterrent, the forbidden sector is further protected by a final, and perhaps most definitive, barrier, an immense and inexplicable wall of radiation. This isn't the predictable radiation of a pulsar or the gentle background hum of the cosmos. It is a chaotic, swirling maelstrom of high-energy particles that forms a lethal shell around the entire region. Imagine trying to observe a castle not just shrouded in fog, but surrounded by a perpetual, invisible firestorm, a storm that scrambles sensors, fries electronics, and would cook any living organism in a matter of seconds. This radiation barrier is the primary reason why even the most ambitious proposals for a manned mission have been immediately shelved. It represents a wall of pure, undiluted death that our current technology cannot hope to breach. Attempts to map this radiation field have yielded more confusion than clarity. The first clue came from gamma-ray telescopes, which detected an intense, steady glow emanating from the sector's boundaries. Gamma rays are the most energetic form of light in the universe, typically produced by the most violent events imaginable: supernova explosions, neutron star collisions, or matter falling into black holes. Yet the gamma radiation from the forbidden sector doesn't behave like it comes from a single cataclysmic source. Instead, it appears as a smooth, uniform shell, as if the entire region is encased inside a perfect, spherical bubble of glowing, high-energy light. Even more baffling is the spectrum of this radiation. When scientists break light down into its constituent wavelengths, it acts like a fingerprint, revealing the elements and processes that created it. The radiation from the sector's barrier doesn't match the fingerprint of any known celestial phenomenon. It's an unrecognizable jumble of energies, a chaotic signature that suggests a process of particle acceleration and emission that we have not yet discovered or cannot yet comprehend. The practical implications of this barrier are staggering. For observation, it means that any probe we send must be equipped with shielding so thick it would be rendered nearly immobile, like trying to explore a jungle while encased in a bank vault. Even then, the radiation is so potent and of such a strange character that it would likely penetrate any shielding we could realistically launch, blinding cameras and scrambling computer brains long before the probe could gather any useful data from within the sector itself. It acts as a perfect cosmic quarantine, ensuring that whatever secrets lie at the heart of the anomaly remain isolated and untouched. This explains why our best images of the sector's interior are so blurred and fragmented. We are trying to peer through a turbulent, boiling atmosphere that exists in the vacuum of space. The origin of this incredible energy field is one of the sector's most heated debates. One school of thought suggests it could be a natural, albeit extreme, magnetic phenomenon. Perhaps the invisible masses at the sector's core generate a magnetic field of unimaginable strength, one that whips charged particles into a frenzy, accelerating them to near light speed and creating a permanent radiation belt that dwarfs anything found in our own solar system. Another, more unsettling theory proposes that the radiation is not a byproduct but a defense mechanism. If there is some form of intelligence or complex structure within the sector, this lethal barrier could be a deliberately engineered shield, a keep-out sign written in the language of gamma rays. It would be the ultimate deterrent, a way to ensure that only those with technology advanced enough to bypass it could ever hope to enter, effectively locking the door to any curious but undeveloped civilizations like our own. Whether it is a natural fortress or an artificial one, the result is the same. The radiation barrier makes the forbidden sector not just mysterious but fundamentally and perhaps permanently inaccessible. Beyond the radiation and gravitational chaos, the anomalies within the forbidden sector appear to extend their influence into a dimension even more fundamental, the flow of time itself. Some of the most controversial and mind-bending data to emerge from the failed probes concern temporal distortions, with onboard atomic clocks reporting measurable, physical discrepancies that challenge our understanding of causality. These aren't the predictable time dilation effects predicted by Einstein's theory of relativity, where gravity or velocity can slow time in a consistent, equation-friendly way. What was recorded were erratic, nonsensical, and deeply unsettling jumps in the very tick of the clock. The most famous example comes from the ill-fated Kronos probe, which we mentioned earlier. As it approached the sector, its array of hyper-precise cesium atomic clocks, the same technology that defines the international standard for a second, began to drift. But they didn't all drift in the same direction or at the same rate. One clock might suddenly race ahead, gaining a full nanosecond over its identical twin mounted just meters away, while another would seem to stutter, falling behind before snapping back into sync. It was as if time within the probe itself was becoming fractured and unstable, with different parts of the vessel existing in slightly different moments. The probe's final, infamous transmission, which contained data time-stamped from its own future, was the ultimate expression of this temporal chaos. It suggested that for a brief moment, the flow of information within the probe was disconnected from the linear cause and effect reality of mission control, creating a paradox that remains utterly unresolved. But the Kronos probe wasn't an isolated incident. Review of data from earlier, less sophisticated missions revealed smaller, previously dismissed anomalies. The Daedalus array, in the milliseconds before its destruction, recorded a burst of data from its internal systems that showed a sequence of events happening in reverse. According to its own logs, a power surge was registered before the capacitor that caused it had even begun to discharge. This isn't just a clock error, it's a violation of causality, a suggestion that within the sector's influence, effect can precede cause. If verified, this wouldn't just be a new astronomical phenomenon. It would represent a fundamental breakdown of the logical framework upon which all of science is built. Theoretical physicists are grappling with concepts once confined to speculative fiction to explain these observations. One leading hypothesis involves the concept of space-time foam. At the quantum level, the vacuum of space is theorized to be a bubbling sea of virtual particles and tiny, short-lived wormholes. The idea is that within the forbidden sector, this quantum foam could be amplified to a macroscopic scale. A spacecraft passing through such a region wouldn't be moving through smooth spacetime, but through a churning ocean of microscopic temporal vortices. Each clock on the probe could be dipping in and out of these tiny bubbles where time flows at a different rate, creating the patchwork, inconsistent drift that was observed. It would be like sailing a ship through a sea where every few feet the water suddenly has a different density and current. An even more radical theory suggests that the sector might not contain an object but an event, a cosmic trauma frozen in time. Some mathematicians have proposed models involving a time crystal, a hypothetical structure that exhibits periodic motion in its ground state, essentially marking time without expending energy. A sufficiently large and complex time crystal could create stable, localized regions of altered temporal flow. Alternatively, the sector could be the scar of a collision between our universe and another in the multiverse, a place where the very laws of time were wounded and never healed correctly, leaving behind a permanent kink in the fabric of causality. These temporal mysteries present a unique and profound problem for any future exploration. How do you design a mission to study a place where the rules of sequence and consequence may not apply? A probe could record invaluable data, but if that data is time-stamped from the future or its internal log is causally scrambled, how could we ever trust its findings? It introduces a philosophical nightmare alongside the engineering one. The forbidden sector doesn't just threaten to destroy our spacecraft, it threatens to invalidate the very process of observation and measurement, turning reliable data into paradoxical nonsense. This layer of the mystery suggests that the sector's greatest defense might not be radiation or gravity, but an inherent incomprehensibility that protects its secrets by making them impossible to rationally convey. Given the sheer scale and consistency of the anomalies, it's almost inevitable that one of the most captivating theories to emerge is that we are not looking at a natural phenomenon at all, but at something artificial. The idea that the forbidden sector could be the domain of a civilization so advanced that their technology is indistinguishable from the laws of nature itself is a hypothesis that straddles the line between cutting-edge science and profound speculation. This isn't about little green men in flying saucers. It's about a concept known as a Kardashev Type 2 or even Type 3 civilization, a society that has harnessed the total energy output of its star or even its entire galaxy. For a civilization operating at that level, engineering on a cosmic scale would be not just possible but routine. The sector's perfect radio silence, its impenetrable radiation barrier, and its ability to disable our probes could all be interpreted not as natural defenses but as deliberate ones, a sophisticated, no trespassing sign written across the stars. One of the most detailed frameworks for this idea is the zoo hypothesis, which suggests that Earth, and perhaps our entire region of space, exists within a kind of galactic wildlife sanctuary. An advanced civilization, or a consortium of them, could have long ago established rules for non-interference with developing worlds like our own. The forbidden sector in this scenario wouldn't necessarily be their home. It could be a regional headquarters, a research outpost, or a transit hub. Its forbidding nature acts as a clear boundary marker, ensuring that species which haven't yet reached a certain technological or ethical maturity cannot stumble into areas they are not prepared to encounter. Our probes aren't being destroyed out of malice, but as a consistent, automated response, much like an electric fence discouraging a curious animal from entering a restricted area. The bizarre final image from the Centauri 7 probe, that negative star field, could have been a final, incomprehensible warning or simply a glimpse of a reality filtered through a technology our minds cannot process. A more unsettling variation is the planetary park or archaeological preservation theory. What if the sector isn't a base of operations but a protected site? It could contain the ruins of a civilization that predates humanity by billions of years, a relic so ancient and valuable that it is cordoned off from the rest of the galaxy. The radiation barrier and gravitational chaos wouldn't be a shield for those inside, but a security system to protect what's inside from outsiders. Our attempts to explore it are seen as a threat to a priceless galactic heritage site and are neutralized with automated efficiency. This theory answers the Fermi paradox, where is everybody? With a sobering possibility, they are all around us, but they are respecting the sanctity of a place we are recklessly trying to invade, treating us not as peers, but as vandals approaching a protected museum. Then there is the possibility of a matryoshka brain or a Dyson sphere on an unimaginable scale. A matryoshka brain is a hypothetical megastructure that encircles a star, built layer upon layer to capture and utilize nearly 100% of its energy for immense computational processing. A civilization that built such a structure would essentially be living within a simulated reality, having uploaded its consciousness into a digital universe of its own design. The Forbidden Sector could be the site of such a project, utilizing the energy of not one star but several. The strange energy signatures and gravitational anomalies we detect could be the waste heat and gravitational byproducts of this incomprehensible computer running processes we cannot even conceive. The radio silence makes perfect sense. A civilization that has retreated into a perfect simulation would have no need to broadcast its presence to the outside world. They wouldn't be hiding from us, they would be utterly indifferent, their entire existence and history playing out within a realm we can never access. Critics of these extraterrestrial hypotheses rightly point out that they often veer into God of the gaps reasoning, using an advanced alien civilization as a catch-all explanation for any phenomenon we cannot immediately explain with known physics. The scientific principle of Occam's razor suggests that the simplest explanation, usually a natural if unknown one, is more likely to be true than an extraordinarily complex one involving unknowable intelligences. Yet, proponents counter that the consistency and coordination of the sector's defenses, the way it perfectly nullifies every form of observation we attempt, exhibits a pattern that feels intentional. Natural phenomena are often messy, inconsistent, and leave behind clues. The Forbidden Sector, in contrast, presents a clean, unified front of impossibility. It behaves less like a chaotic cosmic weather pattern and more like a system designed with a purpose. Whether that purpose is protection, preservation, or simply privacy, the implication is the same. We may be looking at the work of minds whose motives and methods are so far beyond our own that their actions appear to us as nothing less than magic. This theory doesn't just suggest we are not alone. It suggests that the neighborhood we live in has rules and landlords we are only just beginning to perceive. Of course, the truth may be far stranger than any intelligence, and many scientists posit that the sector's bizarre properties could stem from natural, if utterly exotic, physical processes we have yet to understand or observe anywhere else in the cosmos. One of the most compelling ideas revolves around the concept of quantum foam, a turbulent foundation to reality that is usually only relevant at the submicroscopic scale. According to quantum mechanics, empty space is not truly empty. It is a seething, bubbling sea of virtual particles that constantly pop in and out of existence, creating a frothy, chaotic substrate beneath the smooth spacetime we experience. The theory suggests that within the forbidden sector, this quantum foam could be amplified to a macroscopic level. Imagine not a calm ocean of space, but a raging, tempestuous sea where the very fabric of reality is unstable. In such an environment, the bizarre sensor readings and the failures of our technology begin to make a twisted kind of sense. A probe passing through wouldn't be traveling through a void. It would be plowing through a churning medium where the laws of physics fluctuate wildly from 1 millimeter to the next. This could explain the erratic behavior of atomic clocks, as different parts of the vessel experience slightly different flows of time. The perfect radio silence could be a result of this frothy space actively absorbing or scattering electromagnetic waves, preventing them from traveling through or escaping the region. It wouldn't be a deliberate jamming signal. It would be the natural state of a universe where the background chaos has been turned up to an 11. Another fascinating natural hypothesis involves the existence of a vast swarm of primordial black holes. These aren't the stellar mass black holes formed from collapsing stars, but hypothetical, much smaller black holes that could have been created in the immense density of the Big Bang. They could range in size from a mountain to an atom, but would still possess the incredible density and gravitational pull of their larger cousins. A dense cluster of these ancient objects, lingering in the space between Alpha and Beta Centauri, could account for the sector's phantom masses and the chaotic gravitational lensing. Their combined gravity would warp light from background galaxies into those fractured, shifting mirages, while their small size and complete blackness would make them virtually undetectable except through their gravitational influence. The radiation barrier could be the result of intense Hawking radiation, a theoretical process where tiny black holes emit particles as they slowly evaporate, released on a colossal scale from billions of these tiny, dying objects. A probe venturing into such a swarm would be bombarded from all directions by this radiation and subjected to wildly fluctuating gravitational tides, which would easily explain the violent, compressive destruction witnessed in missions like the Daedalus Array. This theory paints a picture of the sector not as an engineered structure, but as a cosmic graveyard, a haunted house filled with the invisible, decaying remnants of the universe's violent birth. A third, and perhaps most mind-bending, natural explanation involves a concept known as a Bose-Einstein condensate, but on a scale so immense it defies belief. In laboratories on Earth, scientists can cool certain gases to a fraction of a degree above absolute zero, causing the atoms to lose their individual identities and merge into a single, unified quantum state known as a superatom. This condensate exhibits strange properties like frictionless flow and quantum behavior visible to the naked eye. Now extrapolate that to an interstellar scale. What if the forbidden sector contains a vast, diffuse cloud of an unknown form of matter that has naturally settled into a cosmic-scale Bose-Einstein condensate? Within this cloud, the normal rules of physics would be suppressed. Light and radio waves would lose their energy and be absorbed, creating the perfect silence. The matter in this state would have negligible interaction with normal matter, explaining why we can't see it, yet its collective mass would still exert a gravitational pull, accounting for the invisible masses. A spacecraft entering this region would experience a sudden and catastrophic loss of energy as its atoms tried to interact with this super-cooled quantum soup, leading to immediate systems failure. This theory suggests the sector is not a violent place, but an utterly cold and still one, a place where the universe has, quite literally, gone to sleep, entering a state of perfect quantum harmony that is utterly hostile to the warm, chaotic, and energetic processes we call life and technology. Each of these natural theories offers a glimpse into a universe far more complex and wondrous than we often assume, where the answers to our biggest mysteries may not lie in the hands of others, but in the unexplored extreme corners of physics itself. With such a profound and unsettling mystery hanging in the heavens, it was perhaps inevitable that official silence would breed rampant speculation. The consistent failure of scientific instruments to pierce the sector's secrets has led a growing number of people to ask a different kind of question. What if the truth isn't unknown but merely hidden? This line of thinking gives rise to one of the most persistent and controversial threads surrounding the forbidden sector, the theory that government agencies and military organizations around the world are actively concealing the truth about what lies within. The foundation of these conspiracy theories often points to the sudden and total classification of all data related to the sector following the catastrophic failure of the Centauri 7 probe. Prior to that event, while the sector was certainly a baffling scientific puzzle, research papers and telescope data were shared with a degree of openness within the international astrophysics community. After the probe's disappearance, a palpable curtain of silence descended. Freedom of Information Act requests for related documents from space agencies and defense departments are consistently denied, not just on the grounds of national security, but under a newer, more vague classification known as cosmic security, a designation with no clear legal precedent. This shift from open curiosity to extreme secrecy is for many the first and most compelling piece of circumstantial evidence that something truly paradigm-shattering was discovered, something the authorities believe the public cannot be allowed to know. This narrative is fueled by a steady trickle of alleged whistleblower accounts from within the aerospace and intelligence communities. These individuals, often speaking under conditions of anonymity through encrypted channels, tell stories that diverge wildly from the official line of ignorant failure. One recurring claim is that the Centauri 7 probe did not simply vanish, it was briefly contacted. According to these accounts, in the seconds before it was lost, the probe transmitted a complex data stream that was immediately sequestered into a black-budget project. This data allegedly contained not just the final glitched image, but a coherent mathematical constant repeated on a loop, a constant that does not correspond to any known natural law or physical property. Another common claim from these sources is that the various probes did not all fail due to random, hostile physics. Some, they suggest, were deliberately swatted down by a non-human intelligence residing within the sector, an action interpreted not as an attack but as a boundary enforcement, and that this conclusion is detailed in classified threat assessment documents. The most famous of these alleged insiders is a figure known only by the pseudonym Serenity, who released a series of memos to a select group of journalists. Serenity claimed to be a data analyst who had worked on the periphery of a joint task force between several national space agencies. Their memos described the existence of a secret international treaty, not to explore the sector, but to quarantine it and actively discredit any scientific inquiry that gets too close. The motive, according to Serenity, is not malice, but a calculated decision by world governments that the truth is too destabilizing for human society to absorb. The memos suggest that the sector is not an empty anomaly, but is in fact teeming with structures and activity, and that revealing this would cause a complete collapse of our cosmological, theological, and sociological frameworks. Of course, the official response to all of this is a firm and uniform denial. Authorities dismiss whistleblower accounts as hoaxes, the work of attention seekers, or the misinterpretation of mundane data by low-level personnel without proper clearance. The classification of data is explained as a necessary precaution to prevent technological secrets related to advanced propulsion and sensor systems from falling into the hands of geopolitical rivals, and to avoid causing unnecessary public panic over a phenomenon we cannot control or understand. They argue that leaping to conclusions about alien megastructures is a fantasy that ignores the more likely, if still unknown, natural explanations. From this perspective, the cover-up is not a concealment of contact, but a prudent management of public perception and national security in the face of a profound scientific unknown. This creates a perfect and perhaps unsolvable paradox. The very nature of a successful cover-up is that it leaves no concrete evidence for outsiders to find. The lack of evidence becomes the evidence itself for believers, who see the official silence and dismissal as proof of its success. For skeptics, the absence of any verifiable physical proof, a clear photo, a piece of debris, a document that can be undeniably authenticated, is proof that the conspiracy theories are built on sand. This standoff means the debate often has less to do with the forbidden sector itself and more to do with a fundamental question of trust. Do we trust the scientific and governmental institutions that guide our understanding of the world? Or do we believe that those institutions are capable of orchestrating a deception of literally cosmic proportions? The silence from the stars is now mirrored by a silence on Earth, and it is within this echoing quiet that the most extraordinary stories are born. Yet this elegant and optimistic formula, a cornerstone in the search for extraterrestrial intelligence, runs into a profound and unsettling contradiction when we apply it to the region between Alpha and Beta Centauri. By all accounts, this sector should be a beacon of potential life, a prime candidate for a positive result in the Drake equation. We know it contains a high number of stars, many of which are stable, long-lived main sequence stars similar to our own Sun. Our observations confirm the presence of protoplanetary disks and several confirmed exoplanets orbiting within the habitable zones of their parent stars, worlds where liquid water could theoretically exist. The value for F sub L, the fraction of planets that actually develop life, should be a number greater than 0 here. And given the age of the stars in this region, which are billions of years old, there has been more than enough time for intelligence to evolve and for a technological civilization to arise, making the final factors of the equation, F sub I and F sub C, also potentially significant. The equation practically demands that this region should be humming with activity, filled with the radio whispers of countless civilizations. Instead, we are met with the great silence. The forbidden sector doesn't just return a value of 0. It actively demonstrates a value that seems to be negative, a void that actively suppresses the very signals the equation predicts we should find. This presents us with what scientists call the Drake equation anomaly, a glaring exception to the rule that forces us to reconsider the variables we thought we understood. Perhaps the factor F sub L, the fraction of planets that develop life, is not as high as we hope. Maybe the journey from simple life to complex, intelligent life is not an inevitable progression but a series of unlikely evolutionary bottlenecks, making F sub I, the fraction that develops intelligence, vanishingly small. Or perhaps the most terrifying possibility lies in the final variable, L, the length of time such civilizations release detectable signals. What if the average lifespan of a technological civilization is not millions of years, but merely a few centuries? This is the concept of the Great Filter, a hypothetical barrier that prevents life from progressing to an interstellar stage. And the forbidden sector might be presenting us with chilling evidence that such a filter is real and insurmountable. The anomaly pushes us to consider that the equation might be missing a crucial variable altogether, one that accounts for cosmic-scale existential threats or for the conscious choice of advanced intelligence to remain silent. The Drake equation operates on the assumption that life, once it becomes intelligent and technological, will naturally seek to broadcast its presence and expand. But what if the opposite is true? What if the ultimate sign of a civilization's maturity is not expansion, but a conscious and deliberate turn inward? A species that has mastered its environment, solved its energy needs, and perhaps even transcended its biological form, might have no desire to explore the physical galaxy or communicate with nascent, potentially violent civilizations like our own. Their entire societal focus might shift to internal, digital, or philosophical pursuits that leave no detectable electromagnetic trace. In this scenario, the forbidden sector wouldn't be an anomaly to the Drake equation. it would be the perfect example of its final, silent answer. The cosmos may be filled with life that has simply graduated beyond the need to shout into the void, leaving curious newcomers like us to wonder if we are truly alone in a universe that has instead chosen to become quiet. Perhaps the most thrilling and deeply speculative explanation for the forbidden sector's bizarre properties is the idea that we are not looking at a place at all, but a passage. This theory ventures beyond the idea of alien megastructures or exotic matter and into the realm of theoretical physics, proposing that the sector is home to a stable, macroscopic wormhole, a tunnel through the fabric of space-time itself, acting as a gateway to another point in our universe, another time, or even another dimension entirely. While this sounds like pure science fiction, it is a concept with a firm, if speculative, foundation in Einstein's theory of general relativity. The equations allow for such shortcuts through the cosmos, known as Einstein-Rosen bridges, though they are thought to be incredibly unstable, collapsing instantly under their own gravitational forces before anything could ever hope to pass through. The radical proposal for the forbidden sector is that something or someone has found a way to hold one open. This could elegantly explain the sector's most confounding anomalies. The intense, chaotic gravitational lensing and the phantom mass readings would be the direct result of the wormhole's immense gravitational mouth warping the space around it. The perfect radio silence could occur because any signal directed into the sector doesn't hit a wall or get absorbed. It simply passes through the gateway and emerges light years away or into another reality, leaving behind only a perfect null void. The bizarre radiation barrier could be the energetic signature of the exotic matter or energy required to keep the tunnel's throat from collapsing, a theoretical substance with negative energy density that would repel rather than attract. Even the reports of temporal distortions from the lost probes find a chilling explanation. Wormholes are not just tunnels through space, but potentially through time as well. A probe passing too close to a stable wormhole could experience severe time dilation or even causal loops, its own signals becoming scrambled across its past and future. The implications of this theory are staggering in their scope. If this is a natural wormhole, it would be the most significant astronomical discovery in human history, a ready-made stargate that could instantly transport us to a distant part of our own galaxy, cutting journey times from millennia to moments. It would revolutionize our understanding of the universe, turning it from a vast, empty ocean into a network of potential shortcuts. But the interdimensional theory pushes this even further. What if the gateway doesn't lead to another place, but to another universe altogether, a separate reality with its own unique laws of physics? This could account for the reports of physical impossibilities, like the Centauri 7 probe's temperature reading of absolute zero. The probe might have briefly sampled the conditions of a universe where the fundamental constants are different, where the very definition of temperature and energy operate under alien rules before the connection was severed. This leads to the most extraordinary and unsettling possibility of all, that the wormhole is not natural but artificial. A Kardashev Type 3 civilization, possessing mastery over energy and spacetime itself, could have constructed this gateway as part of a vast transportation network. The sector's defenses, the radiation barrier, the gravitational chaos, the tendency to destroy probes wouldn't be malicious acts, but simply the side effects of an immense and incomprehensible engineering project, or perhaps a security protocol to prevent unauthorized access. Our attempts to explore it would be akin to ants trying to investigate a particle accelerator. We are simply not equipped to interact with the technology without being destroyed by its peripheral effects. The gateway might be permanently active, a bustling interstellar freeway we are too primitive to perceive or use, explaining why the sector seems both empty and full of impossible activity at the same time. We are not looking at a home but a harbor, and our tiny, primitive probes are being swept away by the wake of cosmic ships we cannot even see. Yet the very conditions that appear so hostile to life as we know it force us to expand our understanding of what life could be. If we set aside our Earth-centric biases, the forbidden sector might not be a dead zone, but a cradle for forms of existence so alien we lack the language to describe them. Astrobiology has long theorized about life based not on carbon and water, but on silicon in the searing heat of a volcanic world, or in the liquid methane lakes of a frigid moon. The sector presents environments that could make those worlds seem tame by comparison. What kind of biology could evolve in a place where gravity fluctuates wildly, where time may not flow in a linear fashion, and where the primary energy source is not starlight but the chaotic bleed-off of distorted spacetime or the Hawking radiation of primordial black holes? We might be looking at the potential for life that perceives the universe in an entirely different way, beings that experience multiple moments simultaneously due to temporal distortions, or creatures whose very bodies are quantum-entangled networks, existing in a stable state only within the sector's unique and violent physics. Their metabolism might not be chemical, but based on manipulating the fabric of reality itself, drawing sustenance from the energy of vacuum fluctuations or the gravitational tides washing through their home. The destruction of our probes might not be an attack, but simply an inevitable result of our crude technology intruding upon an ecology of existence that is utterly invisible and incomprehensible to us, like a submarine suddenly imploding as it dives into a realm of pressure it was never designed to withstand. This line of thinking leads to a profound and humbling possibility. The great silence might not indicate an absence of life, but a presence of life that operates on a completely different communicative framework. Our entire SETI program is built on the assumption that an advanced civilization will use radio waves or optical lasers, technologies that are logical steps in our own technological development. But what if that is a hopelessly primitive assumption? A civilization that has mastered its environment to the degree implied by the sector's anomalies may have moved beyond electromagnetic signaling entirely. Their communication could be based on quantum entanglement, manipulating dark energy fields, or sending messages through manipulations of spacetime itself. Modes of transmission that are as undetectable to our current instruments as a radio broadcast would be to an ancient Roman. We are listening for a whisper in a crowded room, while they might be having a conversation by rearranging the very architecture of the room. The silence, then, is not a sign that no one is home. It is proof that we are listening on the wrong frequency, using the wrong dictionary, and perhaps asking the wrong questions. The sector may be teeming with activity and discourse, a galactic internet operating on a bandwidth of reality we cannot yet access. This redefines the entire astrobiological imperative. The search for life can no longer be just a search for planets with Earth-like conditions or for radio signals. The forbidden sector stands as a monumental lesson that life, in its most advanced and unexpected forms, might thrive in the places we once considered hellish and impossible. It challenges us to develop new tools and new theories, to look for biosignatures not in oxygen atmospheres, but in the anomalous stabilization of gravitational fields or the efficient harnessing of chaotic energy. It suggests that the universe's most fascinating biology might not be found on pleasant, warm worlds, but in the heart of cosmic tempests, in the crushing depths of gravity wells, or in the quiet, ordered structures hidden behind impenetrable barriers. The sector doesn't close the door on finding extraterrestrial life. It blows it off its hinges and reveals a universe of possibilities far stranger and more wonderful than we ever dreamed. Our next great discovery may not be a signal from a distant planet, but the realization that we have been living next door to a different kind of living cosmos all along, separated not by distance, but by a fundamental gap in perception. Yet for all the scientific wonder, the enigma of the forbidden sector is rapidly colliding with a much more terrestrial force, the powerful engines of economics and geopolitics. The immense cost and risk of space exploration have historically been the domain of national governments, but the potential economic value of the sector is now drawing intense interest from a new class of players, private aerospace corporations. The prevailing legal framework for space, the Outer Space Treaty of 1967, states that no nation can claim sovereignty over celestial bodies, but it says nothing about the resources one might extract from them. This has created a legal gray area that companies are eager to explore. Imagine a scenario where the sector's exotic physics could be harnessed. If the gravitational anomalies or the theorized dark energy concentrations could be understood, let alone replicated, they could unlock revolutionary technologies, propulsion systems that bend spacetime, energy sources that dwarf fusion, or materials with impossible properties. For a private company, being the first to patent even a sliver of that understanding would guarantee not just wealth, but a permanent monopoly over the next epoch of human technological development. This isn't just about planting a flag, it's about controlling the blueprint for the future itself. This corporate gold rush is forcing national space agencies into a delicate and unprecedented dance of collaboration and competition. On one hand, the technical challenges are so profound that no single nation or company can overcome them alone. This has led to the formation of fragile international consortiums, like the Joint Centauri Research Initiative, where NASA, the European Space Agency, Roscosmos, and others pool data and share the astronomical costs of developing hardened probe technology capable of surviving the radiation barrier. These alliances are built on a shared recognition of the scientific prize and the existential risk. On the other hand, beneath the public handshakes and memorandums of understanding, there is a fierce, quiet race for positional advantage. Nations are filing detailed flight plans with international regulators for future missions, not just to claim transparency, but to establish precedents and right-of-way in a region that has no clear traffic laws. Satellite networks are being repositioned to ensure optimal communication windows with future assets near the sector, a move that is both practical and strategic, carving out spheres of influence in the high frontier. The ultimate expression of this new space race is the quiet but rapid development of what analysts are calling fortress probes. Unlike their scientific predecessors, these are not vessels designed purely for discovery. They are engineered for survivability and, critically, for claim staking. Funded by public-private partnerships, these probes are equipped with hardened electronics, advanced AI pilots capable of making split-second navigational decisions without waiting for commands from Earth, and even proprietary payloads, essentially automated laboratories owned by corporate entities. The unstated mission of these craft is not just to gather data, but to physically occupy strategic positions within the sector's periphery, to plant corporate logos on any stable surface they might find, and to establish a permanent, active presence that could form the basis of a future legal claim for resource extraction rights. It is a shift from exploration to colonization, driven by the terrifyingly high stakes. The sector is no longer just a cosmic mystery. It has become a potential economic zone, and every nation and corporation is maneuvering to ensure they have a seat at the table when, or if, its secrets are finally unlocked and its unimaginable resources become available for the taking. But if we truly wish to grasp the most cutting-edge and mind-bending explanation for what might be happening, we must venture down to the very smallest scales of existence, to the very fabric of reality itself. This brings us to one of the most compelling and radical theories to emerge from the forefront of theoretical physics, the quantum vacuum hypothesis. At its heart, this idea proposes that the forbidden sector is not defined by what is in it, but by what is missing from it, or more precisely, by a fundamental change in the nature of the empty space that constitutes it. To understand this, we need to redefine what we mean by nothing. We often picture the vacuum of space as a perfect, sterile void, but quantum physics tells us this is utterly wrong. What we perceive as empty space is actually a seething, bubbling foam of incredible activity. At the quantum level, pairs of virtual particles and antiparticles are constantly popping into and out of existence, borrowing energy from the vacuum for an impossibly brief moment before annihilating each other and returning it. This chaotic dance is happening everywhere all the time, and it's not just theoretical. We can measure its effects, such as the Casimir effect, where two metal plates placed extremely close together in a vacuum are gently pushed together by the pressure of these virtual particles outside them. This quantum foam is the background static of the universe, the lowest energy state we know, often called the false vacuum. The quantum vacuum hypothesis suggests that within the forbidden sector, this fundamental ground state of the universe is different. It's possible that a more stable, lower-energy true vacuum exists. Think of it like this: our universe might be existing in a valley, but there could be a much deeper valley next to us that we just haven't slipped into yet. The sector could be a place where, due to some unknown past event, a collision with another universe, a unique concentration of dark matter, or simply a random quantum fluctuation, a bubble of this true vacuum has formed. Within this bubble, the laws of physics would be rewritten. The fundamental constants, the strength of gravity, the mass of an electron, the speed of light, could be completely different from our own. This would elegantly explain nearly all of the sector's anomalies in one fell swoop. The profound radio silence occurs because the quantum noise that normally fills space and allows for the propagation of electromagnetic waves simply doesn't exist there. The vacuum is truly empty and stable, unable to support the vibrations we call light and radio. The bizarre gravitational lensing and phantom masses could be the result of gravity itself operating with a different strength, warping space-time in ways our equations cannot model. The catastrophic failures of our probes become tragically understandable. A spacecraft built from atoms that depend on our universe's specific electromagnetic forces and nuclear binding energies would simply come unraveled upon entering a region where those forces no longer apply in the same way. Its atomic structure might dissolve, or it might be instantly transformed into an exotic form of matter governed by a new, alien set of physical laws. This theory transforms our perspective of the sector from a place that contains strange objects to a place that is the strangeness, a wound in the canvas of reality where the underlying paint has a different composition. It is no longer an astronomical mystery to be solved with bigger telescopes, but a profound philosophical challenge that questions the very consistency of our universe. Studying it would be the ultimate experiment, offering a glimpse into the meta-laws that govern all possible physics. The forbidden sector under this light is not a dead zone. It is a window showing us not what else is out there, but what else reality itself could have been. The profound mystery of the forbidden sector, a puzzle that has stubbornly resisted all scientific inquiry, has done something remarkable. It has effortlessly leaped from the pages of academic journals and into the very heart of our collective imagination. Long before it had an official name, the concept of a forbidden, unknowable region of space was a recurring theme in our stories, a dark canvas onto which we could project our deepest hopes and fears about the cosmos. When science provided a real-world anchor for this archetype, it didn't just validate those stories, it supercharged them, creating a feedback loop between discovery and creativity that continues to shape how we see our place in the universe. This influence is most vividly seen in the explosion of science fiction literature and film that uses the sector as a direct inspiration. Best-selling novel series like Ilara Vance's The Centauri Silence depict it not as a void, but as a galactic nature preserve, overseen by ancient, patient custodians who enforce strict non-interference laws with terrifying efficiency. The sector's impenetrable silence becomes a narrative device, a source of dread and wonder that forces human characters to confront their own insignificance. On the silver screen, its legacy is clear in blockbusters such as Event Horizon. Retribution, and the critically acclaimed series Fringe World, where missions into the sector serve as a modern-day equivalent of a journey into the underworld. These stories almost universally portray the region as a place that doesn't just test technology, but that fundamentally warps and judges the human psyche, reflecting our own anxiety about venturing into the unknown and the potential price of knowledge. Beyond direct references, the sector's cultural impact is felt in the way it has reshaped archetypes. The classic optimistic image of first contact, a friendly exchange of information under a twin sun, has been increasingly joined by a newer, more cautious archetype, the concept of the quiet galaxy. This idea that the most advanced civilizations may choose silence over communication has seeped into everything from video games to philosophical debates. It suggests a universe where the ultimate sign of intelligence is not a desire to connect, but a desire to remain hidden, perhaps for our own protection or for theirs. This has given rise to a more nuanced and sometimes darker genre of space exploration stories, where the goal is not to find a welcoming community of stars, but to carefully navigate a cosmos that might be full of sleeping giants we dare not wake. The sector has also become a powerful metaphor in our daily language and artistic expression. Musicians have composed ambient, dissonant symphonies titled Forbidden Sector, using atonal arrangements and sudden drops into silence to mirror the alleged phenomena. Contemporary artists create installations of fractured light and distorted mirrors, inviting viewers to step into a space where perception is unstable. Psychologists even use the term informally to describe a mental state of profound withdrawal or a traumatic memory that is too painful to access, a personal void that resists all exploration. It has become a shorthand for the ultimate mystery, the final frontier of the unknown, whether that frontier is in the stars or within ourselves. This cultural absorption transforms the sector from a distant astronomical curiosity into something deeply personal. It is no longer just a subject for scientists, it is a story we are all telling together. Each novel, film, song, and piece of art is a collective attempt to process what the existence of such a place means for humanity. It forces us to ask big, philosophical questions that everyone can grasp. Are we alone? And if we are not, is being ignored somehow worse? The Forbidden Sector, in all its silent, imposing mystery, holds up a mirror to our own fears about isolation, about what might be watching us from the shadows, and about the terrifying possibility that some doors in the universe are not meant to be opened. Faced with such an impenetrable mystery, you might think scientists would simply throw up their hands in defeat. Instead, the unique challenges of the Forbidden Sector have become the mother of invention, spurring a breathtaking renaissance in observational technology. The old tools, radio telescopes, optical arrays, even gamma-ray detectors have hit a wall, consistently returning gibberish or nothing at all. So, the global scientific community is responding by building an entirely new toolbox, pioneering devices so advanced they feel like they belong in the next century. This isn't just about building bigger versions of what we already have. It's about reimagining the very fundamentals of how we perceive the universe. At the forefront of this revolution are quantum sensors, devices so sensitive they can detect the faintest whisper of a gravitational wave or the subtle tug of a magnetic field 1 billion times weaker than Earth. Traditional sensors are like trying to listen to a symphony with earplugs in. They're overwhelmed by the sheer force of the sector's radiation barrier and chaotic energy. Quantum sensors, however, operate on an entirely different principle, leveraging the bizarre laws of quantum mechanics to achieve near-miraculous precision. One of the most promising technologies involves atom interferometry, where clouds of atoms are cooled to near absolute zero, placing them into a delicate quantum state. In this condition, the atoms become exquisitely sensitive to tiny changes in their environment. A passing gravitational wave or a fluctuation in a dark energy field would cause these supercooled atoms to wiggle in a specific, detectable way. It's like trying to detect a single pebble dropped in a still pond from 1,000 miles away. The ripples are infinitesimally small, but with the right tools, they are there. These sensors are being designed to be launched on a new generation of heavily shielded autonomous probes. Their mission to map the sector's gravitational and temporal anomalies not from a distance, but from within the storm itself, translating the invisible forces into a data stream we can finally understand. But collecting the data is only half the battle. The other half is making any sense of it. This is where another technological titan enters the fray: artificial intelligence. The sector doesn't just give us silence, it gives us noise, a cacophony of scrambled signals, glitched images, and paradoxical sensor readings that human brains and traditional computers are utterly unequipped to parse. Early attempts to analyze the data resulted in what scientists grimly call the nonsense cascade, where one inexplicable reading would corrupt the entire dataset, leading supercomputers down logical rabbit holes that ended in gibberish. The new approach is to fight fire with fire, or rather, to fight chaos with a different kind of order. Teams at research institutions and private aerospace firms are now training sophisticated AI neural networks on simulated models of the sector's proposed conditions. These AIs are not programmed with rigid physical laws that we know are being broken. Instead, they are taught to look for patterns within the chaos, to find the hidden signal in the noise without any preconceived notions of what that signal should look like. These AI-powered analysis tools are learning to identify what researchers call structured anomalies, repetitive glitches, fractal patterns in the radiation static, or mathematical constants hidden within the scrambled data packets from the lost probes. The most advanced systems are even being designed to operate in real time aboard future missions, making millisecond adjustments to a probe's trajectory and sensor suite based on what it's detecting, essentially allowing the spacecraft to think for itself and navigate the sector's hazards like a skipper reading the wind and waves. This represents a fundamental shift from passive observation to active, intelligent exploration. We are no longer just sending cameras and microphones into the darkness. We are sending artificial minds, built to perceive a reality that our own senses are fundamentally incapable of processing. The hope is that these silicon pioneers will be our interpreters, translating the sector's impossible language into something we can begin to comprehend, finally cracking a cosmic code that has remained unbroken for centuries. Faced with a mystery of such magnitude, no single nation or agency could hope to tackle it alone. The sheer complexity and immense cost of developing the specialized technology needed to even look at the forbidden sector has forged an unprecedented era of international cooperation in space science. This isn't a competition, it's a collective human endeavor, a global response to a puzzle that transcends borders and politics. The primary engine of this collaboration is the Joint Centauri Research Initiative, or JCRI, a consortium that brings together the brightest minds and deepest pockets from NASA, the European Space Agency, Roscosmos, the China National Space Administration, and the Indian Space Research Organization, alongside contributions from dozens of universities and private research institutes. The JCRI operates on a foundational principle of radical data sharing. Every byte of information, from the faintest gamma ray flicker to the most puzzling gravitational wave reading, is instantly uploaded to a secure, decentralized network accessible to all member scientists. This open-source approach has created a global brain trust where a physicist in Mumbai can run simulations on data collected by a telescope in Chile, whose results are then verified by a team in Germany. This collaborative spirit has given birth to some of the most ambitious astronomical projects in history. The Event Horizon Telescope Array, which famously captured the first image of a black hole, has been retasked and massively expanded for the Centauri campaign. By synchronizing radio telescopes across all 7 continents and even in orbit, scientists have created a virtual observatory the size of Earth itself, offering a resolution so sharp it could theoretically pinpoint a baseball on the surface of the Moon. The goal is to peer through the sector's turbulent radiation shell, not with one giant eye, but with thousands of smaller ones working in perfect harmony, using sophisticated algorithms to computationally cancel out the interference. Similarly, the newly operational Einstein Gravitational Wave Observatory, or EGO, network has dedicated a significant portion of its duty cycle to listening for the faint ripples in spacetime emanating from the sector. While traditional astronomy is blinded by the radiation barrier, gravitational waves pass through it unimpeded, offering a clear, undistorted channel of information about the massive, invisible objects warping space within the void. Beyond mere observation, the JCRI is spearheading the development of next-generation exploratory technology. The initiative's crown jewel is the Proxima project, a multi-stage plan to finally penetrate the sector. The first stage, already underway, involves sending a fleet of small, cheap, and disposable Pathfinder probes on high-speed slingshot trajectories through the sector's outermost layers. Their sole mission is to fail, but to fail informatively. Each probe is equipped with a different type of shielding and sensor suite, and by analyzing how each one is destroyed or disabled, engineers can slowly reverse engineer the sector's defense mechanisms. The data from these sacrificial missions is then used to design the second stage vessel, a heavily armored, AI-piloted fortress probe currently dubbed Odysseus. This craft is being designed not for a quick flyby, but to enter a stable, highly elliptical orbit within the sector, using its AI brain to make real-time navigational decisions to avoid hazards that occur faster than a signal can travel back to Earth. Every component, from its quantum-entangled communication system theoretically immune to scrambling, to its hexagonal, ablative armor plating, is the product of shared research from labs across the globe. This monumental effort, funded and built by a coalition of nations, represents humanity's best and most unified attempt to finally answer the question that has haunted us for centuries: what lies in the forbidden darkness between the stars? This relentless drive to explore, to push back the frontiers of the unknown, forces us to confront a series of profound and deeply unsettling ethical questions. The very act of reaching out toward the forbidden sector, of prying into its secrets, may carry risks that extend far beyond the loss of a probe or the waste of a budget. We are forced to ask ourselves, do we have the right to investigate something that has so clearly and consistently demonstrated its capacity for harm, and whose ultimate nature we cannot possibly comprehend? This is not a simple matter of scientific curiosity. It is a fundamental question of cosmic responsibility. The precautionary principle, a cornerstone of ethical conduct here on Earth, suggests that in the face of potential catastrophe, the burden of proof falls on those who wish to take an action to demonstrate its safety. Yet, how can we possibly prove that probing the sector is safe when every attempt to do so has ended in failure? We are, in essence, conducting an experiment with an unknown outcome on a galactic scale, with humanity, and perhaps all life on Earth, as the unwitting subjects. This debate becomes even more charged when we consider the possibility that the sector is not empty. If the theories of an intelligence or a form of life are correct, then our actions take on a colonial dimension. Our probes, however well-intentioned from a scientific standpoint, could be perceived as invasive, offensive, or even an act of war by whatever might reside there. Imagine an advanced civilization sending robotic scouts into our atmosphere, buzzing our cities and scanning our deepest military and scientific installations. Our response would not be one of welcoming curiosity. It would be one of immediate and decisive defensive action. The consistent destruction of our probes might not be a mindless natural phenomenon, but a deliberate and measured response to a perceived threat. By continuing to send them, are we essentially poking a bear of unimaginable power with a stick, simply because we want to see what it will do? The potential consequences of such provocation are unthinkable, ranging from a localized defensive strike to a retaliatory response that could threaten our entire planet. The ethical imperative in this light might be one of radical humility and restraint, of learning to listen rather than to shout into the void. Furthermore, the potential risks may not be confined to a direct military or diplomatic response. The sector's bizarre physics, particularly the theories involving altered quantum vacuums or temporal distortions, suggest that our interference could have unintended and irreversible consequences for the fabric of reality itself. Tinkering with such forces could be likened to performing open-heart surgery with a rock. Our tools are too crude and our understanding too primitive to predict the outcome. A worst-case scenario might not be an invasion, but a chain reaction. Our intrusion could inadvertently destabilize the sector, causing its properties to expand or its anomalies to bleed into surrounding space. We could unknowingly trigger a vacuum decay event, where our universe's fundamental state catastrophically shifts to a more stable one. A wave of new physics spreading outward at the speed of light, rewriting the laws of nature and erasing everything we know from existence in an instant. While this sounds like the plot of a science fiction novel, it is a legitimate, if highly speculative, theoretical possibility raised by some physicists. The ethical question then becomes starkly simple. Is our curiosity worth the potential end of all life in the galaxy? This places an immense moral burden on the scientists, engineers, and policymakers who are steering this research. Unlike past explorations on Earth, where the risks were largely borne by the explorers themselves, the risks here are existential and collective. There is no informed consent from the global population for an experiment that could, in a worst-case scenario, end the world. The decision-making process cannot be left to a small group of specialists or corporate entities with a vested financial interest in the outcome. This demands a new level of global, transparent dialogue and governance. We need to establish international treaties and ethical frameworks specifically designed for contacting or investigating unknown cosmic phenomena. Frameworks that prioritize the precautionary principle and the survival of humanity over national prestige or corporate profit. The forbidden sector is not just a scientific challenge, it is the ultimate test of our species' maturity. It asks us whether we can temper our boundless curiosity with wisdom, whether we can approach the universe not as conquerors but as respectful guests, and whether we can recognize that some doors, once opened, can never be closed again. Despite the daunting track record of failure, the spirit of exploration is far from broken. In fact, the mystery of the forbidden sector has ignited a new generation of mission plans, each more ambitious and technologically daring than the last. The international scientific community is not retreating. It is regrouping, learning from past losses, and designing a new wave of robotic ambassadors specifically engineered to survive the sector's onslaught. Leading this charge is NASA Centauri Explorer, a mission that represents a quantum leap in both design philosophy and technological capability. Slated for launch in the late 2050s, the Centauri Explorer is the antithesis of the probes that came before it. Where previous missions were built for a single, focused objective, this craft is a multi-purpose scientific fortress. Its most striking feature is its shielding, a layered composite of advanced nanomaterials and a constantly circulating coolant that forms a regenerative ablative shell, designed to absorb and dissipate the intense radiation that crippled its predecessors. Rather than relying on a few delicate gyroscopes for navigation, it employs a distributed network of redundant stellar trackers and a revolutionary quantum inertial guidance system that is theoretically immune to the sector's bizarre gravitational and temporal distortions. The probe's sensor suite is equally revolutionary. It moves beyond traditional electromagnetic observation, which has proven so futile, and instead is packed with next-generation quantum gravity gradiometers and vacuum fluctuation monitors. These devices are designed not to see light, but to directly map the warping of spacetime itself, to feel the subtle tremors in the fabric of reality that our current instruments can only hint at. Perhaps its most critical feature is its AI pilot, an onboard neural network trained on millions of simulated scenarios of sector conditions. This AI has one primary directive: survival. It is authorized to make real-time, millisecond decisions to alter the probe's trajectory, adjust its shield configuration, or even temporarily power down non-essential systems to avoid a perceived threat, all without waiting for a command from Earth that would take over 4 years to arrive and return. The Centauri Explorer is not just a probe, it is an intelligent, adaptive entity built to think on its feet in an environment where the very rules of physics are unpredictable. But NASA is not alone in this endeavor. The potential scientific and even economic payoffs of unlocking the sector's secrets have catalyzed a surge of interest from private aerospace giants. Companies like SpaceX with its Starship platform and newer entrants like the Breakthrough Starshot initiative are proposing missions that take a radically different approach. Their strategy often favors numbers and speed over brute force fortification. Breakthrough Starshot's concept involves launching a swarm of thousands of tiny, gram-weight probes propelled by powerful ground-based lasers to achieve a significant fraction of light speed. The idea is that by sending a vast fleet, the loss of individual probes becomes statistically acceptable. Even if 99.9% are destroyed by the radiation barrier or gravitational chaos, a handful might survive long enough to transmit a few precious kilobytes of data back to Earth, a single, clear image or a stream of clean sensor readings that could crack the mystery wide open. This high-risk, high-reward approach reflects a new, disruptive philosophy in space exploration, where agility and volume are leveraged against a seemingly impenetrable problem. Simultaneously, international coalitions are pooling resources for even more grandiose projects. The European-led Ariadne mission concept envisions not a single probe but a constellation of them. The plan is to deploy 3 identical vessels to positions around the sector's periphery, forming a massive interferometer in space. By having these probes take synchronized measurements from different angles, scientists could create a detailed 3-dimensional map of the gravitational and energy anomalies within, triangulating the location and shape of the invisible masses and energy sources. It's akin to using multiple ears to pinpoint the location of a sound in a dark room. This coordinated effort would provide context that a single flyby could never achieve, potentially distinguishing between a natural phenomenon like a cluster of black holes and an artificial structure of unimaginable scale. These planned missions, from the heavily armored Centauri Explorer to the nimble Starshot swarm, represent humanity's collective ingenuity rising to meet an extraordinary challenge. They are not repeats of past failures, but thoughtful, evolved responses built upon decades of hard-learned lessons. Each mission carries with it the hopes of answering questions that have lingered for centuries, of turning a page from speculation and fear toward a first glimpse of genuine understanding. The journey into the forbidden sector is entering its most critical and exciting phase, a testament to our unwavering desire to look into the darkness and demand to know what is there. Dr. Aris Thorne, a senior astrophysicist at the JCRI, has spent 4 decades trying to solve the riddle of the radio silence. Her office is a tapestry of data walls papered with decades of signal graphs, all of which drop to a perfect, flat zero the moment they intersect the sector's boundary. She recounts the moment in 2035 when her team thought they'd finally broken through. A new, ultra-sensitive array in the Australian outback picked up a faint, repeating signal, a simple mathematical prime number sequence that seemed to originate from just inside the forbidden zone. For 72 hours, the entire astronomy world held its breath. Then, as teams globally rushed to confirm the finding, the signal vanished, not faded, not drifted. It was simply erased from all recordings as if it had never existed at all. The only proof was the initial printouts in Dr. Thorne's hands. She describes the experience not with disappointment but with a sense of profound awe. It wasn't a failure, she often tells her students. It was a demonstration. Something out there demonstrated that it can create a signal and then retroactively remove it from reality. We are not just dealing with a barrier, we are dealing with a mind or a mechanism that operates on a level where cause and effect are merely suggestions. On the engineering side, Dr. Kenji Tanaka, who led the design team for the Daedalus array, carries the weight of his probe's destruction not as a professional setback but as a personal mystery. The array was his life's work, a vessel packed with gravitational wave detectors so sensitive they could measure the space-time ripple of a planet forming 1,000 light-years away. The final milliseconds of data recovered from a heavily shielded secondary black box showed something that defies all engineering logic. Every system on the probe reported a massive gravity spike, but the readings weren't consistent. The front sensor reported a pull equivalent to a black hole, while the rear sensor, just meters away, registered absolute zero gravity. According to the laws of physics, this is impossible. Gravity affects everything in a region equally. Dr. Tanaka's voice still carries a note of disbelief when he describes it. It was as if the probe wasn't in one place anymore. It was straddling two completely different universes, each with its own set of physical laws. The stress of that schism is what tore it apart. We didn't design for that because we never conceived of it. How do you design for a reality that is fundamentally fractured? Then there are the more intimate, almost spiritual accounts from technicians and junior researchers who work the long, lonely night shifts at remote observatories. Maria Flores, a data analyst at the Atacama Large Millimeter Array in Chile, recalls a night of exceptionally clear skies. She was monitoring the real-time data feed from a telescope trained on the sector's boundary when she saw it. A single, impossibly bright star that winked into existence for exactly 3 seconds directly in the center of the forbidden zone. It wasn't on any chart, and it didn't match the signature of a supernova or any other known transient event. But the truly inexplicable part was what happened next. The facility's aging guard dog, a normally placid Labrador mix sleeping in the corner of the control room, suddenly lifted its head and let out a low, mournful howl at the exact moment the light appeared on her screen, falling silent the instant it vanished. There was no way the animal could have seen the monitor. For Maria, that chilling synchronization between a celestial event and a terrestrial animal's instinct was a humbling reminder that the sector's influence might not be confined to the cold realm of data. It might resonate in ways we are only beginning to sense, connecting with something ancient and deep within the living world in a language we have yet to understand. These personal stories form the human heartbeat of the mystery. They are not just data points, they are experiences that have shaped careers and reshaped worldviews. They remind us that behind the complex equations and the sophisticated machinery, the quest to understand the forbidden sector is driven by individuals who have stood at the edge of the known universe and felt the cold wind of the unknown on their faces. Their collective testimony paints a picture of a phenomenon that is not merely strange but interactive, responsive, and perhaps even conscious, challenging its observers not just technically but philosophically and emotionally, demanding a new way of seeing not only the cosmos but our place within it. And so we find ourselves here at the edge of the known, staring into a void that has captivated and confounded us for centuries. The forbidden sector between Alpha and Beta Centauri stands as a monument to the limits of our understanding, a cosmic sphinx whose riddles we are only beginning to formulate. We are left with a collection of profound mysteries that defy easy explanation. The great silence, that perfect and unnerving radio void, suggests a form of cosmic stealth technology or a natural phenomenon that absorbs all energy. The phantom gravitational masses, colossal objects that exert an undeniable pull yet remain completely invisible to every instrument we possess, hint at matter or energy operating under laws of physics we have yet to discover. The impenetrable radiation barrier acts as a lethal quarantine, a wall of pure energy that protects the sector's inner secrets from any prying eyes, and the scattered, heartbreaking accounts of technological failure and temporal distortion paint a picture of a region where reality itself becomes unstable, where cause and effect can unravel and time may not flow in a linear fashion. Each of these enigmas is compelling on its own, but together they form a puzzle of breathtaking complexity and scale. This relentless pursuit of the unknown, this drive to push beyond the next horizon, is one of humanity's most defining and beautiful traits. Our journey with the forbidden sector is a microcosm of our entire relationship with the cosmos. It is a story that begins with ancient astronomers noting a curious absence on their star charts, evolves through generations of scientists building ever more sophisticated tools to peel back the layers of the mystery, and continues today with global collaborations and revolutionary technologies designed to finally, perhaps, glimpse the truth. It is a quest fueled by an insatiable curiosity, a need to not only map the stars but to understand our place among them. Whether the sector ultimately reveals itself to be a nest of primordial black holes, a pool of concentrated dark energy, a stable wormhole, or something beyond our wildest imaginings, the act of seeking the answer is in itself a profound achievement. It represents our refusal to accept ignorance, our courage to confront the terrifying and the sublime, and our unwavering belief that the universe, no matter how strange, is ultimately knowable. The conversation does not end here. In many ways, it is just beginning. This mystery belongs not just to scientists in observatories, but to anyone who has ever looked up at the night sky and felt a sense of wonder. So now we turn to you. What do you believe lies within that silent, dark expanse? Do you find the natural explanations of quantum foam or dark energy more compelling? Or does your imagination lean toward the possibilities of ancient megastructures and hidden civilizations? Perhaps you have a theory of your own that we haven't even considered. The greatest discoveries often begin with a spark of intuition, a new way of looking at an old problem. Share your thoughts and ideas in the comments below. Let's continue this exploration together because the universe is vast, its stories are endless, and the next great revelation could come from any one of us looking up and daring to ask